AI systems move sensitive data through prompts, APIs, retrieval, logs, datasets, and outputs. In this module, we'll focus on protecting that data at each step with controls such as tokenization, masking, redaction, and encryption, designed into the architecture from the beginning. We've already covered the foundations: identity, secure applications, and API protection. Now we'll connect those layers to the data itself, where exposure can occur in prompts, logs, documents, outputs, and datasets. In AI workflows, sensitive data rarely stays in one place. It may enter through a user prompt, be added by system instructions, expanded through retrieval, and then appear again in completions or tool calls. RAG introduces additional exposure points because documents, chunks, embeddings, metadata, and citations may all contain protected content. Logs, telemetry, evaluations, fine-tuning data, and agent memory can preserve that exposure long after the original request is complete. Classification is the control plane for AI data protection. Start by identifying every asset the system touches, not only documents and databases, but also prompts, outputs, embeddings, annotations, and telemetry. Then assign a sensitivity level from public to highly sensitive. That label should drive what the system is allowed to do, who can access the data, whether it must be encrypted or redacted, how long it is retained, and what logging is appropriate as it moves downstream. One of the strongest privacy controls is keeping unnecessary data out of the AI system entirely. For prompts, send only the context needed for the task, not extra user or account details. For retrieval, narrow results with permissions, metadata filters, and relevance thresholds. For logging, prefer summaries, hashes, or samples instead of full prompts and outputs. And for training or evaluation, define the approved purpose, so data is not reused beyond its original intent. Tokenization gives teams a practical way to keep sensitive values out of AI workflows. Before data reaches prompts, logs, analytics, or a model provider, names, account numbers, emails, and identifiers are replaced with safe substitutes. The mapping stays in a protected token vault, not in the AI system. Authorized services can re-identify data when a business process requires it. Treat that vault as critical infrastructure with strong access control, encryption, audit logging, and separation of duties. Masking reduces exposure while preserving enough usefulness for the task. Static masking shows the same hidden version everywhere. Dynamic masking changes visibility based on role or context. Partial masking leaves limited detail, such as the last 4 digits, so support teams can verify a record without seeing the full value. Apply masking before data enters logs, dashboards, analytics, or AI prompts. Just remember, masking is not encryption, and it does not eliminate inference risk. Removing direct identifiers is only the first step. People can still be singled out when ordinary details combine, such as city, age, role, timestamp, or an unusual event. I adds more pathways, because embeddings preserve meaning. Metadata travels with content, and outputs may reconstruct patterns from highly specific context. Manage this risk before prompts, training, analytics, or sharing by reducing precision, aggregating records, suppressing rare cases, applying differential privacy where appropriate, and restricting access to the minimum necessary. Redaction should operate around the entire AI workflow, not just as a pre-processing step. Before inference, scan prompts, uploaded files, retrieve documents, and tool responses for sensitive material such as PII, health data, payment data, secrets, or confidential IP. After generation, inspect the response before it reaches a user, log, or application. The basic sequence is detect, classify, redact, validate, and then deliver, with human review when confidence is low. Policy-based DLP provides a control layer around AI interactions. It evaluates prompts, uploads, API payloads, retrieved content, responses, logs, and generated files against defined data rules. Based on the finding, the system can allow, block, redact, quarantine, or alert. The key is bidirectional inspection. Protect the model from receiving sensitive input, and protect users and systems from receiving sensitive output. Effective programs also tune policies over time to reduce false alarms and missed leaks. Encryption has to follow AI data everywhere it lives and moves. At rest, that includes datasets, logs, embeddings, vector indexes, model artifacts, snapshots, backups, caches, and temporary storage. In transit, use TLS or MTLS across users, APIs, retrieval, queues, model endpoints, telemetry, cloud services, and service-to-service paths. Also verify third-party AI providers. Their encryption controls and contract terms must match the sensitivity of the data you send them. Encryption depends on strong key governance. Centralize keys in a KMS or an HSM for higher assurance, so applications do not handle raw secrets casually. Enforce least privilege by separating encryption, decryption, administration, and rotation into distinct powers. Keys also need lifecycle controls, including rotation, revocation, versioning, and audit trails. For regulated or highly sensitive AI workloads, customer-managed or bring-your-own key models provide stronger ownership and accountability. Observability is necessary, but it should not become a second data lake of secrets. Treat every prompt, completion, trace, and evaluation record as potentially sensitive. Before telemetry reaches a central platform, remove what you do not need, redact or tokenize what remains, sample aggressively, and set retention limits. Then protect access with role or attribute controls, encryption, environment separation, and auditing. Finally, monitor the logs themselves for leaked credentials, PII, and debugging artifacts. Data assets should be managed like production databases with added controls for meaning. Before content enters a RAG pipeline, classify and sanitize it. As it is chunked and embedded, keep lineage, sensitivity labels, and encryption attached. At retrieval time, enforce permissions on every document and chunk, not just the original repository. Protect embeddings as well, because they can expose relationships and proprietary concepts. Then apply retention, deletion, backups, and audits across the full AI data lifecycle. Data protection is an end-to-end discipline. Sensitive data can surface in prompts, outputs, logs, embeddings, retrieval systems, and storage. Strong programs minimize and classify data, then apply tokenization, masking, redaction, DLP, encryption, key governance, retention, and access control. Next, we'll connect these controls to cloud and workload security.